Let's apply a little more sophistication to the chain rule, and quite honestly, you're not going to see the benefit of it right away. You have to have faith that math instructors know where you're headed in the world of calculus, and sometimes it may seem a little bit more difficult or convoluted to go to another approach, in this case to do the chain rule, but later when you see where we're headed, you realize, oh, I'm glad I took the time to understand what's going on now, because it's going to pay big dividends to me in the future. And the way to learn advanced math, I think, is to understand the concepts as solidly as possible so you can synthesize, so you can apply things intelligently to new situations, because it's not a problem to transfer from lower level problems to more advanced when you really understand the relationship that's going on between the concepts. So here we go. Again, if we have a situation where we have a function of a function, that's when we use the chain rule. And we looked at it before that we could do things this way, and that's all cool. But what we might want to do is use U substitutions and V substitutions. So it basically works like this. You could have y be a function of a function of a function. And it's as simple as going to the innermost function and saying, I'm going to let u equal that, and then go out to the next function from that standpoint, and we'll say v is equal to that. And then once you go out to the outside function, you'll say y is equal to that whole thing. So then by doing it that way, you'll just make a chain. That's where it gets its name. You'll say that the derivative of y ultimately with respect to x is to simply take the derivative of y with respect to v, and then the derivative of v with respect to u, and then the derivative of u with respect to x. And what happens is, once we look at the change in y with respect to v, and cancel the change in v with respect to u, and then cancel how u is changing with respect to x, ultimately what's left is dy dx. Now let's see how it works. Let's suppose we have this function here. It's the cube of this function. So what's the function of a function? So we're going to go into the innermost function, 5x minus 1, and we're going to stipulate that u would equal that function, and therefore y would be u to the third power. So there's y, it's defined by u being raised to the third power, and u is defined as equaling 5x minus 1. So then the derivative of y with respect to x is to take the derivative of y with respect to u, and then multiply it by the derivative of u with respect to x. So the derivative of u with respect to x, well, 5x minus 1, that derivative is just 5. And then in green here, if we take the derivative of y with respect to u, it's going to be 3u squared. So we multiply these two things together. Derivative of y with respect to x is 3 times 5, or 15, times u squared. And now just remind ourselves what u is and replace it back with the 5x minus 1. So that's dy dx. No argument that those of you that are really quick with the chain rule can reach that answer a lot faster by just multiplying in front by 3, reducing that by 1, and then multiplying on the outside by 5. There's no argument with that. It's just that long term, when you get to the more sophisticated problems after we introduce trigonometry, exponential, natural log functions, probably teaching yourself how to do use substitutions now will pay big dividends and allow you to get more complex problems correct at a higher rate than if we just keep leaning on our understanding of the simple application of the chain rule. So let's do another one. We got this function. So we go to the innermost function and we say that's u. Then from there we say that y would equal u raised to the 1/2 power. So there's y, there's u. So differentiate u with respect to x, and we get that. Differentiate y with respect to u, and we get this. And make the chain. Dy dx is the product of those two derivatives. So we multiply those guys together. 1/2 of 6 is 3. The x squared is in the numerator. U to the negative 1/2 is the radical of u, and u is 2x cubed minus 7. So this is our final answer, this derivative of y with respect to u. Again, the benefit of the chain rule using u substitutions becomes more evident in the near future. We don't necessarily know yet how to find the derivative of sine. It's going to be cosine. But what we have here, if we look at this, what this is going to be is the function of a function of a function. So it's going to be to take the cube of a sine function, and the sine function is going to be a function of 2x. So how we will do that is we'll say, okay, let's go to this. We'll go to the innermost function. We'll say u is equal to 2x. We'll work our way out from that. We'll say that v is equal to the sine of 2x. Then we'll work our way out from that and just say that y is equal to v cubed. So now all we have to do is take the derivative of y with respect to v, ding, the derivative of v with respect to u, and the derivative of u with respect to x, and multiply them together. So in the end,